Welcome to qnawire.
So now we're going to work on problem 118 from chapter 13. In this problem, we're asked about a glucose solution, which is 10% by mass, and we want to calculate its freezing point, boiling point, and osmotic pressure. So first, let's talk about this glucose solution. If it's 10% mass glucose, what that means is that it's let's assume 10 grams of glucose. And if there's 10 grams of glucose, there's going to be 90 grams of water. So it's the percent mass of glucose is calculated by taking the mass of glucose over the total mass and multiplying by 100. So that would give us 10%. So we're going to need to know the moles of glucose. So we go ahead and multiply or divide the mass, which is 10 grams, by the molar mass, which is 180.156 grams. And we get a value of 0.0555 moles of glucose. So we can directly calculate molality, small m, by dividing these moles by the mass of the water. So we wrote up there that there's 90 grams of water. If we convert that to kilograms, it's 0.090 kilograms. So we do this division and we get a value of 0.617 molality. So we can calculate now the freezing point. So freezing point will be equal to this molality. We ignore the Van 't Hoff factor since it's glucose and will not dissociate. So we multiply the molality by the freezing point constant, and we get a value of negative 1.15 degrees Celsius. And so the freezing point is actually equal to the same thing since we're subtracting it from 0, which is the normal freezing point of water. So just a small correction here, this should be dt since we're finding the freezing point. So now we'll find the boiling point, and so dt will equal the same molality times the boiling point constant, which is 0.512. And that gives a value of 0.316 degrees Celsius. So our boiling point will be 100.32 degrees Celsius. So the last thing we have to calculate is osmotic pressure. So to do that, we need to calculate molarity. We calculated only molality so far. So we need to use the solution density within the mass of the solution. So our total mass would be here 100 grams. So the mass of the solution is 100 grams. And if we divide that by our density, we can convert to volume. The density we're given in the problem is 1.039 grams. And we get a value of 96.25 milliliters. So we already know the volume, the moles up at the top. So m is equal to 0.0555 moles divided by our volume in liters. And we get a value of 0.577 m. And we can calculate now our osmotic pressure. So pi is equal to I, which we can disregard. So times M, which is 0.577, times R, 0.0821 liter atmosphere Kelvin mole. And we're given a temperature of 20 degrees Celsius, so it's 293.15 Kelvin. And when we do this multiplication, we get a value of 13.9 atmospheres, which is our osmotic pressure.